Good afternoon. This is a single subject briefing on the Theater High Altitude Area Defense Interceptor flight test that was conducted this morning at White Sands Missile Base. There are two briefers today. First, Lieutenant General Lester Lyles, who's the director of the Ballistic Missile Defense Office, and Lieutenant General Paul Kern, who is the military deputy to the Assistant Secretary of the Army for Acquisitions, Logistics, and Technology. General Lyles is going to go first, and then General Kern. General Kern has a short video clip that he is going to show, and following those two presentations, we'll take some of your questions. General Lyles.
Okay, good afternoon. Well, this morning at White Sands Missile Range, we attempted to conduct the 9th in a series of flight tests for the Theater High Altitude Area Defense System. This is a critical element of our theater missile defense architecture for the United States and for all of our coalition forces. The primary objectives of today's test were to demonstrate a body-to-body high endo-atmospheric intercept of a unitary target, to demonstrate and characterize the seeker used in the THAAD program, the INSB, indium antimonide seeker used in the THAAD program, to demonstrate the THAAD system closed-loop operation of all the various components involved in the THAAD program in this particular test, and to demonstrate the THAAD radar performance against this kind of unitary target. The test today was conducted, as I stated, from White Sands Missile Range. During the tests, which started roughly at 7:13 Eastern Standard Time when we launched the Hera target, we then 7 minutes later launched the interceptor, the THAAD Interceptor, for one of its launch tubes and its configuration. We did not achieve our primary objective of having a body-to-body intercept of the THAAD Interceptor with the specific Hera target. During this particular test, we got a nominal booster flyout from the THAAD system. We had good performance of some of the various systems or subsystems that have not worked very well on some of the previous intercept attempts for the THAAD program. The flare at the very beginning of the test coming out of the tube worked very, very well. The THAAD energy management steering worked very, very well. The booster and kill vehicle had a nominal separation. We got nominal separation of the shroud around the kill vehicle. We had good command data of the in-flight target updates from the radar, battle management, command and control to the missile. They were providing target information and target map information to the missile. Unfortunately, about 1 minute into flight, we lost the telemetry. And because of loss of that telemetry, we are not able to date at this particular moment to characterize and specifically determine the cause of why we managed to miss the particular intercept. As I stated, we did not have a body-to-body intercept. However, from the radar data and from airborne sensors which were on scene at White Sands Missile Range, we think we came between 10 and 30 meters from having an actual intercept. Unfortunately, again, because of not having the telemetry data, we're unable right now to specifically pinpoint better the closure rate of the two objects, and we're not able to tell you right now what may have caused the particular separation. We're still evaluating all the available data. The two storyboards to my left and to my right sort of define specifically the configuration for the test today at the White Sands Missile Range, shown on the left, with the Hera target, which was launched, the THAAD launch itself, all the battle management, command and control, the launcher and the radar system of the THAAD system, which all worked extremely well together. And then the actual missile, you see from this photo here, you'll see dramatically shown in the video shown by General Kern. The configuration profile for the test itself is shown on my right, with the Hera target shown on the left part of that particular chart, the launcher and all the other configurations that are part of it shown on the right-hand side of the chart. And rather than go into details about the chart configuration and profile, let me ask General Kern to come forward and talk you through to the video, and then we'll both come forward and try to answer any questions you might have. Paul?
Thanks, Les. Let me just take a second to put in my perspective that this is an extremely critical part of our nation's missile defenses. And you know we have built a system of systems between all the services to work effectively together. Last week we had the opportunity to watch a successful PAC-3 shot. This week we had the opportunity to watch not so successful THAAD shot. Nevertheless, a significant improvement over those previous shots that we have seen. We did put the new seeker, as General Lyles mentioned, on board, and we did get a good shot that was not available the last time. So while we are not where we would like to be, I'm encouraged by the test today that we are much closer to achieving success than we have been for quite some time. And again, it is a critical part of that whole compendium of missile defense systems. We have a battalion of soldiers that are trained and ready and waiting for this. They have the ground systems as demonstrated today with the launcher, the radars, and the battle management. And finally, I am convinced that American industry can do this. They have the right technical pieces that they've put together. And I believe that the team, that General Lyles with the Ballistic Missile Defense Office, the Air and Missile Defense Command at Huntsville, and America's industry are very close to complete success in the entire system that we're putting together. So I'm encouraged rather than discouraged by today's shot, and I think that in the next few months you're going to see some real advances made in our ability to demonstrate to you that we can put the entire package together end to end. I'm going to go ahead and dim the lights here in a second. I just would tell you that we saw this film probably not more than about 10 minutes ago. So you're getting to see it almost precisely the same time that we are. We did talk to the program manager as he was on the phone at the airport going through it, and we'll give you a quick description of the shots as we see them. The first thing you're going to see will be the Hera, which is a two-stage rocket built from Minuteman sections that we use as our test vehicle. As General Lyles mentioned, it was fired from northern part of White Sands Missile Range, about 170 kilometers from the THAAD launch point. The entire test in this case takes place over White Sands Missile Range. Go ahead and roll the movie, please. I don't know if you all can see that or not. I can. There's the Hera launch. It will fly to an apogee of about 314 kilometers and will be on the descent when it gets into the intercept phase. The next piece you're going to see is the THAAD launch. It is firing off the THAAD launcher. There it goes. The first maneuver it does, that strange spinning maneuver, is the THAAD energy management steering to burn off energy so it stays within the White Sands Missile Range. It's also used for our low-altitude intercept. You're going to see some sparkling lights that will come up here. Hopefully you'll be able to see them in this light. What the sparkling lights are the controllers, the DACs, that are on the side of the missile that actually steer it towards the target. You're beginning to see that now. And it did not freeze in space, I guarantee you that. The bright spot that came in from the top is the Hera target missile. It's very difficult to see in here. There we go. The launch, the Thames maneuver, and that's a quick replay. Yep. We will have copies of this available for you at DDI afterwards. I can't tell you how soon afterwards. They're making copies of it now. It literally just came in just prior to our walking in here. We're going to try and run that back again? Yeah, the light in here, it is not terribly bright. The predicted intercept that should have occurred would have been about 2.5 minutes after the THAAD launch. And that did not occur, as General Lyles explained, and the THAAD missile self-destructed 10 minutes past that intercept, 10 seconds past that intercept point. The initial results indicate that as I mentioned, in the bright spots, when you see that in a darkened room, I think you'll be able to pick them out, that the Divert and Attitude Control System, the DACS, was performing. It appears that we had the seeker bringing it into that end game, but until we do the final analysis and depending upon the quality of the data we are able to get back, that may take some time to go through that. We will then plan our next shot for late May. Exactly when, I say, will depend somewhat on the ability to reduce the data that we have now and get the next missile ready. And we're shooting, if we were completely successful, we'd have 2 more successful shots by the end of June. And I will just tell you that's going to be a real challenge given the schedule that we have right now. I think that's all I've got. And as I said, copies of that video will be available for you from DDI later.
Okay, at this point, we'll be happy to take any questions that anybody might have. Yes.
Walk through the financial penalties now that Lockheed incurs. Is it $15 million right off the top because they missed today, and then $20 million by the end of June?
Yes. What the question is referring to is the contractor cure agreement, cure notice agreement that we initiated as a result of the last failure that we had, the failed intercept we had on the THAAD program. And it does require that we get a body-to-body actual intercept on Flight Test 9. If not, there is a penalty of $15 million. And I might add, we're not going to get a check from Lockheed Martin. That's not the way this works. Lockheed will just not bill the government for $15 million worth of effort under this particular contract as a result of that particular this particular milestone, or lack of a milestone. The next milestone for this cure notice is that we have 2 successful hits achieved by the 30th of June. The penalty for that is $20 million if we don't achieve that particular milestone. And then there's subsequent milestones associated with different time frames leading up until the end of this calendar year. The total potential penalty is $75 million. Again, not in terms of a check from the contractor, but in terms of lack of billing, or that they do not bill the government for that particular amount of dollars.
Does it look like they're going to have to pay the next 20, given that 2 by the end of June 30th is unlikely?
Do not want to speculate on that. If we're able to find out and pinpoint exactly what the cause was for this particular anomaly, and it's something that can be correctable very, very quickly, we're hoping to stay the line and try to conduct the next test by the end of end of May. And if that's successful, there is a chance we can get a second attempt off, and if that's successful by the end of June, and not have to have that particular penalty come into play.
Are you happy with the way Lockheed improved between May and today in terms of management and quality?
Absolutely, absolutely. They have done just yeoman's work in going back, bringing in leadership and bringing in stronger technical support from throughout the corporation, and actually bringing in experts from other major corporations to help them to get their arms around the problem. Redoing qual testing, redoing component testing, lots of pedigree work to find out the background of literally every nut and bolt in the THAAD system. I am extremely pleased with the performance of Lockheed management and the technical expert in this regard.
I'd add one comment. The other missiles are available. It's not a question of having to build the missiles. It's a question of making sure that what is learned from each shot is then brought forward so that we don't make the same mistakes over again. And I would echo completely General Lyles' comments that we've seen a real turnaround in Lockheed Martin's performance from both management and technical supervision of this program.
Yes.
Valid or not, there seems to be a linking on Capitol Hill between the performance of theater missile defenses, particularly THAAD and national missile defense. Does this particular test give you any pause with NMD, or is there any connection in your mind at all?
None whatsoever. The physics in some aspects are similar, but we're talking different regimes in many respects, and obviously different designs and different systems. I think one of the cautions or concerns that people have had is about hit-to-kill lethality, the body-to-body impact lethality methodology, and whether that will work. Well, we actually proved that 2 weeks ago with our PAC-3 test. PAC-3 is also a hit-to-kill missile, and that was absolutely a perfect test. We learned some things. We had some very, very minor anomalies of things that we learned, which we wanted to learn from that test, but we proved that hit-to-kill is viable and can work. So until we understand better about today's anomaly for THAAD, I would not even have one bit of hesitation relative to our plans and designs for national missile defense.
General Lyles, part of the concern with the first 5 tests was that, or the intercept attempts, was that you never got to the end game. Well, this time you got to the end game, and you didn't get an intercept. So to what extent do you know or do you not know whether the end game design, which is kind of the heart of this, is just flawed?
Let me just add a correction, because I think we've all sort of cavalierly used that phrase, we never got to the end game. If you look over the series of 9 tests that we've had for THAAD, and particularly look at the now 6 anomalies or failures that we've had a couple that actually did get close to the end game. Now, turns out we had seekers that didn't perform properly. One had some contamination, and we had one where we just ran out of fuel at the last few microseconds, if you will, and didn't get the kind of divert that we actually needed. So I'm not quite sure if we can use that statement that we have been using, that we never got into the end game. Nevertheless, we know there have been a couple of failures that have precluded us from actually determining what happens those last critical seconds, last critical fractions of a second. We are hoping that we did manage to get some information on this particular flight. It's going to be very complicated by the fact that we don't have telemetry, at least right now. And so determining what did occur, how the seeker performed, the slew rate of the seekers, how the DACs performed, whether or not they were getting signals from the seeker, all of that is very, very critical to the final design. And we're not sure as of this moment whether or not we had telemetry information that will answer that question.
I would be a little bit more positive, too, in saying that the end game has been proven to be not achievable. Not so at all. Clearly, we demonstrated it's achievable 2 weeks ago with PAC-3, as General Lyles said, but also what we're building today is a series of algorithms that were done in simulation on the ground. And what we have to demonstrate, and that's why it is so important to get the data back from the seeker and the missile flight test, is how they correlate to the algorithms that we're using. Those algorithms are adjusted for the conditions that we expect to see in space, and that's what's so important about that part that we've labeled that end game. So we're not there yet.
Yes.
Did this Hera target fly a much different course than the one used 2 weeks ago?
Yes, it was a completely different profile. Same basic missile, but in this case, a different profile, fired from a different part of the range. This was not fired from Fort Wingate, as was the previous one for PAC-3. So the profile was a lot different, much as you would expect for a medium type of threat of which the THAAD is intended to engage.
I'd also add that PAC-3 is getting ready to go into production, and we're quite a bit earlier in the phase of the testing with the THAAD system, so you wouldn't expect them to correlate identically.
Let me go there, and then I'll come back over here. Yes.
General, as you go into, I know it's only a few months into the new year here, but since you announced the shoot-off sort of competition between THAAD and maybe upper tier, but does this test have any impact? Like if you said, well, how are things going between the 2 programs now? Is one ahead, one behind? Can you look at it all? Yeah,
let me qualify that. And we're trying to avoid any terminology like shoot-off or real competition. What we're trying to do is to allow, at least right now, allow both of the upper tier programs to proceed through their early testing, series of tests that were planned, and try to determine within a couple of years how each system is performing to see if one may have a lead ahead of the other in terms of performance, in terms of management, in terms of cost, et cetera, so that we might have an opportunity to reallocate dollars to that one program that's ahead, make that the lead upper tier system that we try to bring into the inventory for the United States. When you say fly off competition, it sounds like we're intending to kill one of the other program, and that's certainly not the intent at all. It's really to try to make sure that the United States can have an upper tier system to protect our forces, our coalition forces, our warfighters, and to try to have one of them, at least one of them, if not both, fielded as early as possible. As far as this test is concerned, we still have a series of tests left for the THAAD program. We're still several months away before we even have the first Navy upper tier test. So again, we're going to let both programs proceed through their test activities for the next couple of years or so to then determine which program is on the most successful track.
Decide at the end of this year? Which one? Is there a decision at the end of 99?
Not necessarily, because we have not, we will not have flown Navy upper tier at the end of this year. We will have perhaps one controlled vehicle flight of the Navy upper tier if everything stays on track, but not an intercept. The first intercept for Navy upper tier is about a year away.
From the Army's perspective, Navy upper tier and THAAD are complementary. We don't want one or the other. We want both. And that is simple if you go figure out the mathematics of what it takes to protect troops from missile defenses. You want to get as many chances at shooting down an incoming missile as you possibly can. You don't want to put it all on the back of one system or another. Secondly, the information that we learn from these tests, the Navy will benefit from, and the technologies. The Ballistic Missile Defense Office is a joint organization, and it's not exclusionary information.
Yes.
Why did you lose telemetry data, one? And two, in terms of the $15 million payment, is that set in stone? I mean, if you get information back that it was a Hera, there's something wrong, that it wasn't a missile part of the problem, could you then say the Lockheed Martin doesn't have that $15 million penalty?
Okay, that's a good question. Let me answer the first question first. I wish I knew why we lost telemetry. We lost telemetry about a minute into flight. We've not had problems with telemetry on our previous flights, and to date, or at least right now at this particular moment, I cannot tell you exactly what occurred. And we're trying to troubleshoot and find out exactly what could have been the causes and pinpoint exactly what happened here. Your comment is right about the body-to-body intercept, which was the milestone for this particular cure notice agreement we have with Lockheed Martin. We're talking about missile performance. If it turns out we do have, whether it's human error or some problem with the target, then we certainly can't pinpoint or fault Lockheed Martin for that. We don't know that's the case and right now, and so our thought is that we just did not get body-to-body intercept, which is the milestone that they had to achieve. And Lockheed Martin is very much aware of that. I've been talking to the senior leadership of that, obviously, throughout the day.
You don't know yet.
We don't know yet. We think all the performance data we have for the target, we did have good telemetry on the target all the way through completely until impact or destruction. And the target performance was extremely nominal. So the bet is that the target performed very well.
Contractor or not? I mean, the debate about the second contractor coming into this, does this give any further impetus to that?
You mean in terms of some competition for that? Right now we're staying the course relative to prime contractor and team for THAAD. This upper tier strategy that we talked about earlier is the closest we come to looking at whether or not resources are applied more to one program or another. But the bottom line is we do need both systems. Yes.
General, can you please comment on how this new seeker design perhaps differs from the previous design that you used?
It is a different material. We use platinum silicide as the material for the previous seeker. On the last flight test 8, we switched to the indium antimonide material. It's a little easier material to process and make than it was the platinum sil. Has a little bit better performance characteristics. And then there's some lessons learned from other systems. The indium antimonide it's the same material used in the seekers for the Israeli Arrow program that we're helping them to develop, and also used in the Navy Area Defense Program for their IR seeker component. So there's experience we're gaining from all three programs by using that particular material.
The first time General Kern alluded to this, you used new algorithms. Is that correct?
Second time with this seeker. First time didn't prove out to be very successful, if you remember. But the algorithms are something that are built into the system that you have to prove that work between the seeker and the target and the radars to match up all of the flight performance.
Yes.
It just seems to me that there's so many things that can go wrong, and every test that something has gone wrong, like the telemetry went out. You would have to have a perfect system that responded perfectly for this to work in the end. Can you base the national defense on a system like that, where if it's not perfect, the enemy missile comes in? I mean, that's the biggest critical question.
I think General Kern stated it very accurately. We have great confidence in American industry to be able to do this particular job. And while it's complex, it's not the only complex thing we do for our national security needs. there are many other programs that have a lot of complex factors to them. Maybe not these same factors, but there are a lot of things that are stacked upon other areas that have to work perfectly for most weapon systems to perform the way they are intended. I think industry has shown us that they can do this particular job in some various forms. We know the ground systems work very, very well. The radar systems work extremely well. We're having a little bit of trouble trying to get the missile to perform properly, but I have great confidence that we can do this and that our national security, whether from a theater standpoint or a national missile defense standpoint, can be supported by these kinds of technologies.
And one other thing, though, that the telemetry is separate from the battle management command and control system. The telemetry is peculiar to the test part of the program where you put it through the phases so that you can learn and make the next system better. When we go to issue this system to fight, that telemetry is not part of the system. It's part of the BMC cubed I part that ties all these pieces together as well as what's on board the actual missile and seeker.
Can I just ask one follow-up? If you can't get perfection, why did you go away from a system where it's you just want to? Why do you want to do hit to kill? Why can't you just, since you get so close to the missile, just do the fragmentation?
All of our analysis show us that for weapons of mass destruction, you have a much better lethality with body-to-body kinetic impact than you do in taking a chance with a warhead. Taking a chance with a warhead can give you the kind of scenarios that we saw a couple of times, we think, during Desert Storm, where you may knock the warhead out of the way or break it up, but not destroy it to the point that you don't have some sort of damage on the ground. And when you talk about weapons of mass destruction like chemical or biological agents on them, we want to ensure that we have body-to-body impact with enough energy to completely destroy, disintegrate, kill anything that's there. So from lethality methodology, that's the reason hit to kill is so important to us. Yes, John?
General Lyles, you've expressed in the past concern that, in effect, you may have some lemons on your hands here. These missiles were built several years ago. How many more of these older missiles do you have left? And when's the earliest we could start seeing a new batch of THAAD missiles to start testing so we can, there's only so much you can do to an older missile that may have been manufactured improperly.
Okay. I don't think I've used the word lemon, so I'll make sure to get that clarified right away. Yes, we are dealing currently with the test assets with missiles that were built at the beginning of the program, and we have demonstrated that there may be some quality concerns, but that's the area that the contractor has been focusing on, making sure we don't have any more of those, or we're comfortable with what we have for the current family of test vehicles. We have about five of those vehicles left, 5 or 6 of them currently left. We actually are going to make some block upgrades, minor upgrades to improve some of the quality and the design, which will go into effect for the next couple of tests that we currently have. There are some minor things that are already being addressed in the next couple of test missiles. So we're already starting to bring into the inventory some improvements from the original design, improvements from the original configuration that we've been testing for the last 9 series of tests.
After these 5 are shot, though, what then? Is that going to be determined by this review about the upper tier programs?
If these 5 are successful, or 3 of these 5 are successful, technically we're supposed to proceed into EMD of the program, engineering and manufacturing development of the program, which is the next phase, and we will be building new missiles with cleaned up design, some of the things we've learned through the early part of the program for testing in that particular phase of the program. The pace of that effort will be determined by this upper tier strategy, but the basic strategy is to still proceed into EMD.
If they're not successful, is there what's the likelihood that you could have some alternative THAAD program? Try it again, in other words.
We'd have to look at that very closely. We've been studying that and looking at alternative methodologies. I don't want to comment on them right now because I'm, again, very hopeful that things are going to be very successful, but we are looking at some backup plans just in case.
We've got time for 2 more.
General, at which point will you have enough information on the THAAD program versus Navy upper tier to make a decision as to which is the preferred option? 2000, 2001.
We always stated that we wanted to get through a series of tests for THAAD and for Navy upper tier. We said a decision point would be probably the fall of 00, the year 2000, when we would be best equipped to make such a decision. By that point, we should have data on both systems. So roughly, that's the time frame that we've stated. we cut a couple of people out, so I guess we'll take a couple more questions if you don't mind, Mike. One here and then.
If it turns out you don't have telemetry data from this, what will you rely on in order to kind of walk you through the test?
That's going to be very sporty, but it's amazing sometimes how much information the engineers and test people can get out of sporty.
Sporty, okay.
It's amazing how much data people can get from what might seem like a limited amount of information. We have lots of radar data. We have lots of visual data. We have lots of infrared data from 2 different airborne platforms which are flying to observe the test. And we have some indication of something, some kind of data stream that was still coming down, but right now it's not decipherable. And we're going to have to look at that to see if that might be actual data that somehow was not modulated properly or what have you. So we're going to be working with everything we can find, literally, to try to get as much information as we can about this particular test.
Maybe General Kearns can answer this, how long the analysis may take, or that's all subject to what you have to look at?
It's very much subject to what they actually get down when they go recover all the components. They do a forensic analysis to look at that. We'll see what we can learn from that. As General Lyles mentioned, there are a number of other data streams. That can take weeks to go through all that, and part of it on this garbled stream will depend upon what it really takes to ungarble it. It's a lot of deciphering of that information that is available. So it can be anywhere from a couple of days to a few weeks to really get through it all.
But you're much more comfortable with the telemetry if you had not lost telemetry. Take the...
Oh, yes, definitely.
Absolutely.
Definitely. Ann, I think.
General, could you give us some impressions of how the whole system is working together? You've said in the past all the different pieces have been working fine. How does it work as a system? How does it fit into your overall architecture? And when might you be connecting up to other pieces of your architecture?
Okay. For the THAAD system itself, as I mentioned, one of the objectives on this test was to demonstrate the end-to-end closed-loop operation of all the various components. For this particular test, for the first time, we had the UOS radar, as we call it, the User Operational Evaluation System radar, the early radars for the THAAD program, online performing all the different missions or parts of the mission it's supposed to accomplish. We had the Battle Management Command and Control. We had the Tactical Operations Center all working properly. The launcher all worked properly. Everything seemed to work very, very well, with the exception, obviously, of what happened relative to the closing end game for the missile. So from that standpoint, we're closer to having end-to-end closed-loop operation of the THAAD system, which is exactly what we want. How it fits into the total architecture, as General Kern alluded to, our architecture depends on, for the most effective capability for missile defense, multi-tier, multi-platform. Because we want to have as many engagement opportunities as we possibly can, and we certainly want to be able to counter the entire range of threat. And THAAD, the upper tier systems, THAAD and Navy upper tier, are specifically designed to counter the medium range threats, those that operate above 1,000 kilometers, 1,300 kilometers and above, which are the kinds of threats we're seeing being proliferated today. Shahab 3 development by Iran, the North Korean Nodong, the Gari tested by the Pakistanis. Those are the kinds of threats we have to encounter with the upper tier systems. And so we need to have the entire architecture all working well together to give us the most effective missile defense system.
Just to follow, would you be connecting in further tests to, say, Patriot units or something else to test out how your interoperability is?
Yes, we do have interoperability tests planned downstream in the program. And that involves both missile tests, and we've actually already been conducting some limited tests where we have different parts of the architecture working well together. We want to use eventually something like the THAAD radar and use it to cue a Patriot system, or use the THAAD radar to cue a spy radar on a Navy Aegis ship. Those kinds of tests, interoperability tests, are planned for the program within the next couple of years, and it's a major part of the activity because interoperability is a major part of missile defense effectiveness from our standpoint. Okay, thank you very much.